Algebra 2! I hope you guys are having an awesome day. Today we're going to talk about complex fractions. And I'm going to show you two different ways to solve them. You can choose which one you'd like, or you can use both of them, but not at the same time. So, let's get started. So, we have complex fractions. What is a complex fraction? A complex fraction is basically a fraction that has fractions in the numerator or denominator or both. It's a fraction within a fraction. Yay! So, some examples of a complex fraction might be something like a half divided by 2/3, a half over 2/3. Or if we're talking about rational expressions, it could be something like 1 over x plus 1 over x plus 3. So the biggest trick to simplifying these is just writing it out as a division problem. Because dividing, like a big division problem. So you do the numerator divided by the denominator, and then just copy dot flip or multiply by the reciprocal, right? The same way you would normally multiply fractions or divide fractions. All right, so first example is x plus 2 over 3 over x. So what I would do is, if I'm writing it like a normal division problem, I write it as x plus 2 divided by 3 over x. And now since x plus 2 isn't a fraction, we can just make it a fraction by putting it over 1. And then to divide fractions, we just copy the first one, x plus 2 over 1, change it to a multiply, right? Multiply by the reciprocal. Oops. Multiply by x over 3. And then I can just keep simplifying from there. So I do x times, just multiply straight across, x times x plus 2 all over 3, and that ends up equaling x squared plus 2x all over 3. Or you can write that as 1/3 times x squared plus 2x. Another way to write the same answer. Okay, next example is 1 plus 1 over x divided by 4x plus 5. Again, I'm going to rewrite it as a normal division problem. So let's do that first. Okay, now the tricky part with this one is that both of them are not already fractions. So the second number, or the second expression, I can just write as over 1, right? Because that makes it a fraction. But that equals the same thing. But the first one, we have 1 plus 1 over x. So we need to combine those two together and make it one single fraction or one single rational expression. So all you really want to do is find your common denominator and then add the two together, like normal. So my common denominator in here is just x. So I'm going to multiply 1 by x over x and then add. Okay, so I've written the first number 1 as x over x plus 1 over x. And then I'm going to combine those two because now I have a common denominator. So that becomes 1 plus x over x. And now I have a normal fraction division problem. Remember, what is algebra all about? It's about taking things that you don't know what they are and making them, rearranging them and making them look like something where you do know what they are, and then you know what to do with them. So that's what we did. Okay, so I have my division problem. So I copy the first one, change the division to a multiply, and then flip my second fraction. So multiplying by the reciprocal. And now just multiply straight across. 1 plus x times 1 is just 1 plus x. And then x times 4x plus 5, 4x squared plus 5x. And at this point, if we can factor things and cancel them out, we do that. But in this case, that's not going to work. So we just make sure you just include when the denominator is 0, because the rational expression is undefined when the denominator is 0. Remember, bad things happen. So if I set my denominator equal to 0, 4x squared plus 5x, and factor that back out, I get x times 4x plus 5. X cannot equal 0 or negative 5/4. So this is my final answer. Yay! Okay, example 3. Now this is getting nasty. We've got 1 over x plus 1 over 2x divided by x plus 4 over x minus 2. Again, let's rewrite it as a division problem. Okay, now we can't divide these until we have one single fraction divided by another single fraction. So let's do that. In the first part here, 1 over x plus 1 over 2x, we need a common denominator, and that common denominator is 2x. So I can multiply the first one by 2 over 2, and then combine it. So I'm going to have a 2 over 2 that I'm multiplying by, and so then I have a 2 over x, plus, 2 over 2x plus 1 over 2x. And then I can combine those into 2 plus 1, which is 3, over 2x. So that's my first term. All right, now we have a normal division of rational expressions. Just solve it. Multiply by the reciprocal, and then multiply straight across. I've got 3 times x minus 2 over 2x times x plus 4. And if you can cancel things, great, do it. In this case, again, you can't cancel anything. There's no common factors between the numerator and denominator. So all we have to do is figure out when is the denominator, I can talk, denominator 0. 2x is equal to 0 when x is 0. And x plus 4 is 0 when x is negative 4. So those are the two values that x cannot be. Aha! But don't forget, we also, in the beginning, had an x minus 2 in the denominator. So that cannot be 0 either. So x can't equal positive 2 in addition. So let's add that to our list. Comma 2. And then we box it. And that's our answer! Yay! We have some lovely music in the background. Can you hear it? I have no idea who that is. Anyways, okay, another trick. So here's the other method. This is like, it's a more fun method, I guess. I don't know. Is it fun? Whatever. But when you have a complex fraction, you can do the outsides divided by the insides. And it's basically cutting one step out of the previous one. But like, for example, doing example 3, hold on, let me write out that rule for you real quick. Okay, so if you have strictly one fraction over another fraction, you can just do the outsides multiplied together divided by the insides. So like in this case, I have the 3 and the x minus 2 are on the outsides. So I have those multiplied together. I've got 3 times x minus 2. And then I divide that by the insides. 2x times x plus 4. Okay, so that's just another way to do it, another little trick. I kind of like that one if it's like a case where it's very clearly one fraction over another. In some of the other cases where you have to rearrange stuff, you know, like the x plus 2 over 3 over x, you have to rewrite the numerator as a fraction. So, I don't know. Whatever preference, you know, whichever one you like. So I'll show you that with one more example. I'll do it again with example 1, just so that you can see the same thing in action on an example we've already done. But other than that, it's really not that bad. So for this one, example 1, we have x plus 2 over 3 divided by x. So I'm going to actually rewrite that as x plus 2 over 1 divided by 3 over x. And then again, I take my outside terms, which is x plus 2 and x. Bam. Ooh, we even have Christmas music going on right now. Okay, anyways, sorry, I got distracted. So you have the outsides multiplied by each other. So I've got x times x plus 2 divided by the insides, 3 times 1. And so we end up with the same answer as what we got in the beginning. Just a different way to format it, a different way to write it. So, there you go. Let's go see who's playing. Let's take a little trip. Oh, they're little people. Look, they're little people. I thought they were maybe older people that we could talk to, but they're little people, and the younger kids freak me out. Okay, never mind. Maybe I'll go find an older person that you guys can say hi to. Look who I found!
Oh my god, Algebra!
Yay! Algebra!
Yeah!
Who else
what
did I
she
find?
said.
Look! Oh look, there's more people! Say hi! Hello! Say hi! Say hi! Hello, everybody!
For the Algebra
Hello,
video.
hello! Hi! Hello! Have a nice day! What's up?
The Algebra.
This is my math video. Say hi! Hello! Hello! What's up? Okay, can you tell them at Tech Week? What?